right, so in a 0.20 mole HCN solution with a Ka value of 4.9 times 10 to the negative 10, calculate the pH of a solution. So to begin, what we need to do is we need to go ahead and determine our reaction. So first we're going to do our reaction. Sorry if the handwriting is atrocious, but that's what we got. So HCN is going to dissociate into hydrogen ions with our CN. Okay. So next we need to set up our Ka equation. Ka is our acid dissociation equilibrium, and that's going to be our products over our reactants. Okay, same as all of our other equilibrium products, or equations, I'm sorry. So to begin, our Ka value we already know. It's given to us in the equation, so 4.9 times 10 to the negative 10. That's going to equal our hydrogen and our CN concentration over our HCN concentration. Alright, so next we need to go ahead and set up our ice table so we can find out what those concentrations are at equilibrium. So we set up our ice table. Okay, we have our ice table. And our hydrogen, our CN. Okay. So our initial concentration, which is given to us in our equation, is 0.2. Alright, we're going to be losing that at a rate of x. So 0.20 minus x is our concentration at equilibrium. For our reactants, our products, I'm sorry, we don't have any of those initially, so those are going to be 0. But we're going to be gaining those, so we're going to have a plus x on both of those. Alright? So then we go ahead and plug in our values into our Ka equation. So D is plug in. Plug it. Alright, so we have 4.9 times 10 to the negative 10 equals to x times x over 0.20 minus x. Now in this case, what we want to do is we can assume at this point that 0.20 minus x is going to be roughly about 0.20. This is because we believe that the value of x is going to be so minuscule that it's not going to change our overall 0.2 value. Alright, so we go ahead and we solve at this point. So we have 4.9 times 10 to the negative 10 equals x squared over 0.20. Remember, this is because we're assuming that 0.20. So if we solve for x, we have 4.9 times 10 to the negative 10 times 0.20. It's going to equal x squared. I'm going to take the square root of each of those. So your x value, when you're done calculating out, should equate to 9.9 times 10 to the negative 6. Right? So if we look at our table here, we can see our hydrogen, right? It's going to have issues right now. Our hydrogen is the same as our x value, which means that this x here is also our hydrogen concentration. All right, so that means that we have our hydrogen concentration at equilibrium, so now we can go ahead and solve for our pH value, which is what the equation was originally asking. So our pH. All right, so the equation to solve for your pH is pH equals the negative log of your hydrogen concentration. In this case, we're going to have negative log of 9.9 times 10 to the negative 6. Right? When you solve that, your pH will come out to be 5. You can hardly make out. So I'm clean this up a little bit here. All right, so going to be a pH of 5. All right, and that's going to be your answer.